In this lab, we are going to study a sequence of chemical reaction. The reactions will be carried out in a 250 ml beaker. Before we start our chemical reaction, we'll use measuring balance to record the weight. We'll place the beaker on the measuring balance, press the tare, and then place the beaker. We'll record the weight in our lab notebook. Now we'll carefully measure 10 ml of copper nitrate solution using the measuring cylinder and transfer it to the beaker whose weight was recorded before and placed on an ice bath. We will then measure 2 ml of 6 molar sodium hydroxide solution using a graduated cylinder and it added dropwise interval to the copper nitrate solution with constant stirring. We'll observe the change in color from light green to blue and then dark blue. This is a time-consuming as well as very important part of the lab. Here, copper nitrate is reacting with sodium hydroxide to form copper hydroxide and sodium nitrate. This is a typical precipitation reaction where heavy metals form insoluble hydroxide which can be precipitated from solution using soluble hydroxides such as sodium hydroxide. The blue gelatinous precipitate that forms is copper hydroxide. The precipitation of copper hydroxide is not complete until the supernatant liquid is basic. We will then use the litmus paper to check the basicity of the supernatant liquid. We'll take a strip of red litmus paper and place it on a watch glass. We will then use the glass rod to touch the supernatant liquid and then touch the litmus paper to confirm the basicity of the supernatant liquid. The red litmus paper turns blue, which confirms the basicity of the supernatant liquid and the completion of the precipitation reaction. Next, we'll wash the precipitate 3 times with 30 ml, 50 ml, and again 50 ml of water. When we add the water to the beaker, we'll stir the solution and allow the mixture to stand for a few minutes while the precipitate settles. Once the precipitate settles, we'll decant the major part of the clear, colorless supernatant liquid into a waste beaker. This is the third and the final wash, where we'll see clearly the precipitate settling down at the bottom of the beaker. We will then add 3 molar sulfuric acid dropwise with stirring to dissolve the precipitate. This is an acid-base reaction where acid and base react to form salt and water. Here, copper hydroxide react with sulfuric acid to form copper sulfate and water. Once the precipitate is completely dissolved, we will add few pieces of magnesium into it. Here, magnesium displaces copper from copper hydroxide to form magnesium hydroxide and copper as a solid. This is a displacement reaction. This is also an example of oxidation reduction reaction, which involves the change in the oxidation number. This is a slow process. To increase the rate of the reaction, we removed it from the ice bath and continuously stirred the solution. The bubbling is due to the magnesium reducing the proton to hydrogen gas. Once the reaction is complete, we added 6 molar HCl to remove the excess magnesium. We then decanted the liquid to the waste beaker, washed with acetone, and allowed the precipitate to dry. We then recorded the weight of the beaker. The difference in the initial and final weight will give us the weight of the precipitate.